literally so many materials we have to study in such a short amount of time. I don't think I can do this. I'm definitely gonna fail this.
Don't worry, I know you can. We still have more time to study and prepare our best.
Yeah, but I'm not so sure about that.
It will be fine. Okay? Now, enough talking. Let's just start studying.
Okay.
Hey, I noticed that you were unable to focus this whole time. How about the light ascended candle? It has always helped me so I can focus on my work.
Yeah, anything to help me focus and back studying.
Fragrance does more than just make a room smell nice. It can measurably change how your brain and body respond to a task. Inhaled scent has been linked to reduced physiological stress, with studies showing changes like lower heart rate and calmer autonomic activity. So beyond stress, fragrance can also shape cognitive performance. Research by Cafe and colleagues found that scent exposure produced small to medium improvements in memory, attention, and alertness. So lighting a candle while studying is not just about ambience, but it's a sensory input that can genuinely shift your stress levels, focus, and ability to retain what you're learning. Smell starts when the odorant molecules from the candle drift into your nose and dissolve in the mucous lining in your nasal passage, the olfactory mucosa. And there will be receptors which sit directly on tiny hair-like structure called cilia, which stick out into that mucous layer. One odorant molecule can bind into several receptor types, and one receptor type can bind into several odorants. It's combinatorial and not one-on-one match. So when binding is strong enough, it depolarizes the receptor neuron's membrane. And if that crosses the threshold, an action potential fires down the olfactory nerve. That's cranial nerve 1, straight into the brain. So once the signal has entered the olfactory bulb, it reaches a structure called glomerulus. Inside the glomerulus, the receptor axons synapse onto second-order neuron called mitral and peptide cells. Their dendrites extend into the glomerulus to pick up that signal. This is where the brain starts to make sense, which receptors fire together. And the axons of those mitral and peptide cells will bundle together to form the olfactory tract, which projects to the piriform cortex. This is the region that actually identifies the scents as, say, lavender or vanilla, and at the very same time, your prefrontal cortex is doing something else entirely, directing your attention back to what you're studying, even while the background sense keeps shaping your arousal and focus underneath.
Okay, so what Lita just did was reading, and reading is possible because of our visual system. So, what does our visual system do when we're reading? Our visual system is related with multiple brain areas, including our occipital lobe, the prescient cortex, the inferotemporal cortex, and several parts of the cerebral cortex. And so, you might ask, what is the process behind the visual system and how can we read? So, the process starts when light from object enters through the pupil, which its size is regulated by the iris, and it is then focused by the lens onto the retina. And in the retina, the light is converted into neural signals by receptors after passing through 4 layers, which includes retinal ganglion cells, amacrine cells, bipolar cells, and horizontal cells. These signals are then transmitted back out through the layers of the retina and sent to the central nervous system through the retina geniculate striate pathway. From there, the signals reach the thalamus, specifically the lateral geniculate nuclei, before being sent to the primary visual cortex. After initial processing in the primary visual cortex, the information moves to the secondary cortex for more complex processing. It is then sent to the visual word form area, where written words and familiar letter patterns are recognized. Following this, the information is processed in the left language network, particularly in the angular gyrus and Wernicke's areas, where the meaning of the words and language comprehension take place. Finally, the information reaches the association cortex, where it is fully integrated with memory and knowledge, allowing the person to understand what is being read.
Now I will explain the motoric aspect of the study situation. First, during movement planning, the brain prepares our action before they happen. For example, when reaching for study materials, lighting a scented candle, arranging books and notes, or deciding what to do first, these actions are mainly planned by the prefrontal cortex and the secondary motor cortex. Second, during movement execution, the planned actions are carried out. This includes writing notes, highlighting important information, turning pages, and typing on a laptop. These movements are controlled by the motor cortex, while the cerebellum helps coordinate them smoothly and accurately. Third, there is sensory motor integration, which is the process of combining sensory information with movement. For example, our hand movements are guided by visual feedback when writing or typing. We can also detect the candle's scent while studying. In addition, maintaining posture and attention requires continuous coordination between sensory and motor systems. Over time, repeated studying helps improve motor efficiency through motor learning and making this action faster and more automatic. So, even a simple study session involves complex motor processes, from planning movement, executing them, and integrating sensory information to support effective learning.
So now we know how it had affected our motoric system, such as our visual as well, and our olfactory, which is our sense of smell. And now we are going to move on to our memory. So when you inhale a scent, let's say like lavender, it directly triggers a significant decrease in your autonomic arousal. Why? Because this specifically lowers your blood pressure, heart rate, and also skin temperature, which actively knocks down physiological stress. So, when your body isn't in a stressed, high alert state, your brain freezes up and frees up cognitive resources. Instead of managing anxiety, your brain can redirect that energy towards focusing more and taking in a lot more information than you have had before. Now, about the scent, what does the scent actually do to us? So, the exposure that we have gotten from the scent, like lavender, it puts us in a good mood. But how so? Well, it actively alters and triggers cognitive metrics. It creates a measurable small to medium move improvements, specifically in your attention, your alertness, and of course, your memory. So, because the olfactory system has a unique direct pipeline to the limbic system, which is your brain's emotional and memory center, lighting that candle creates an evidence-based link that helps your brain encode, learn, and retain information much more effectively when you study. Let's say that I continuously light up a candle every time I am about to study. The more prolonged that effect is, my brain would link lighting up a candle to the specific information that I am constantly taking in due to the link of the brain's emotional and memory center, which is why it helps a lot with your memory and it doesn't jog it that much. It also kind of helps with brain fog.
Oh, we finally finished studying after those unbearable hours of memorizing and reading.
Yeah, I'm glad we can finish studying tonight. This means we can relax tomorrow.
Yeah, that's exactly what I was thinking. Anyway, thank you for the scented candle idea. It really helped me focus.
No problem, I got you.
So, in conclusion, Studying with a scented candle helps because inhaling the fragrance activates the said olfactory system, which sends signals directly to the brain's memory and emotional centers, which is the limbic system. And this pathway actively lowers physiological stress, dropping your heart rate and blood pressure, which frees up your mental energy. And instead of wasting resources on anxiety, your brain redirects them to power the visual system for reading and the motoric system for writing and typing. Lastly, this biological synergy allows the prefrontal cortex to lock in your attention, making it much easier to focus and retain information.